Most popular parts of the conference. Harold.
And now Jeffrey Armstrong will do his best to get Python 3 running on your Atari desktop. Are you ready?
Yes. Absolutely.
Have you connected your Atari desktop to the projector?
Sort of.
That's great.
Sort of. I love that answer.
Give a big hand to Jeffrey Armstrong.
Yay.
Python 3 on your Atari desktop.
All right, thank you very much. I'm going to talk about putting Python 3 on an Atari desktop. Who here has compiled CPython before? Specifically Python 3. Okay, who has compiled it but not for a Mac, Windows, or Linux? All right, we got a few less hands now. Okay, well, what I'm talking about is the Atari desktop line of computers, and hence the subtitle is going to be, if it comes up, what? Okay, so the Atari computers were built by Atari starting around 1985. They're 68K powered. Thank you. Basically, they started with the Atari ST. Their last two computers, in 93 or so, were the Atari TT and the Atari Falcon. But since then, there's been clones for the Atari also. Basically, we have some 68040 and 060 clones that other companies produced. There's a virtual machine called Aranim that you can use on basically any popular platform, including Atari's, as odd as that is. And also, there's a new clone came out about last year, I think. I might be wrong, called the Firebee. So if you really want to try that, you can actually buy Atari hardware still. So, in the past, I've actually compiled Python 2 for the Atari, but I wanted to do 3 because, let's face it, that's the future, and this would really benefit the tens of users on this platform. So, we're going to go ahead and run configure and then make on our Atari, and guess what? It doesn't work at all. And here's the problem. When we're compiling for the Atari, we're using GCC about 2.95, so a little bit dated, right? But oddly enough, Ataris don't use the GNU libc, so we have a new problem. We use something called the mintlib, which is its own library, its standard library, and it doesn't have any Unicode support that works in any manner. So that led to a little bit of changes. I had to pull in wide character support from a different embedded runtime library, and basically this led to a nice GitHub commit you can see here, 1,553 editions, 64 files change, a little bit of a doozy. I didn't actually write this. This is just pulled in from the Muscle standard library. All right, so if we get the Unicode support in there, let's go ahead and we'll try compiling again, and we can compile. Awesome, we have a Python executable. When we run it, does it work? No, it does not. And guess what's wrong this time? When we go through some debugging trying to figure it out, import doesn't work anywhere, and that means you can't import anything. And what happened was there's actually a little bit of a bug deep in Python in the imp module. Basically, it assumes shared libraries are supported. So import would import load dynamic, but that doesn't work on an Atari, and that led to a nice core Python bug you can see here. So if we fix that bug, I'd say this is probably the first bug on the bug tracker that said Atari in about 3 or 4 years. So, if anybody's noticed, I'm actually running inside the Aranim virtual machine right now. So we're running on an Atari as we speak. And let's go ahead and we'll cd, whoops. So, once we compile, you can see here, I actually have the full suite of Python stuff. Let's try running Python 3. Give it a little second here. Hey, there we go! Looks like things work. It looks like we have some good things from the standard library running. So generally speaking, we have Python 3 running on our Atari. Very exciting. So, oh, and we had a system crash. Well, anyway, I'm not going to be able to reload that PDF by the time my 5 minutes are up. So, if anybody's interested, my Twitter handle is FortranJeff. All right? I bet that doesn't execute right. If you have any other questions, you can see my GitHub account, and you can see all the nonsense I've committed for the Atari standard libraries. And if there's any other questions, you can find me afterwards. Thank you.
Big hand. Woo!
Good job, Jeffrey.
Very good. We need Brian from GitHub.com to come to the front. Also Jay Dunk at Gmail.com and Luke at Contextual.io to
Make your way
yourself-
to the front of the room and stand by the stage,
And now,
please.
some people think that's not planned or something, but we had Jeffrey Armstrong talking about Python 3 on your Atari desktop, and now we have the talk title Armstrong, Open Source News CMS by Joshua Barnett. Are you ready, Joshua?
Yeah.
Cool.
Go, Joshua.
Give him a big hand.
Hi, I'm Joshua Bonnet, the manager of software engineering at the Center for Investigative Reporting. We, along with the Texas Tribune, have written a CMS for online news publishing. I hear you say, why the heck did you write another CMS? To which I would answer, currently stories are managed by emailing documents, images, and videos around at large news publications all over the world. Armstrong is a CMS organized for, or optimized for news organizations. It is an iteration of the code base originally developed for the Texas Tribune, which itself was the basis of the Bay Citizen. Armstrong is the result of rewriting everything with the benefit of the combined organizational knowledge acquired over the last 5 years. We at the Center for Investigative Reporting recently relaunched Armstrong on top of, or relaunched Bay Citizen on top of Armstrong. We just recently began the process of backporting all of the open source code we wrote for this over the last year. Armstrong does some awesome things you want. It does schedulable content, super flexible content categorization, flexible and schedulable authors, related content structures, all sorts of things. It's all built in a modular and extensible way that you can use right now. Even if you're not going to rewrite your whole site to use Armstrong, you can use little pieces of it all over the place, and it makes things much easier. Even more stuff is coming soon. This is all in the Django CMS. Schedulable page layouts, query-backed-filled wells, embedded objects with support for Embedly and YouTube, comments built on top of threaded comments and Backbone, a super easy build system that'll get you up and running in about 5 minutes. That's assuming you already have an AWS account and can't do anything to speed that along, but it's also super modular, schedulable static pages where you can just drop in little bits of content here and there for things like about pages where you're not going to be running like some huge process. And that's it. Right now things are very quiet, but we're planning on moving a lot more quickly in the coming months, so keep an eye on GitHub, and that's it.
Joshua Bonnet,
Thanks very much, Joshua.
Armstrong, the open source CMS.
It's nice to see that the speakers are respecting the spirit of Lightning Talks, which is that they can last up to 5 minutes, but they don't have to last 5 minutes. So we do have a little more time than we actually anticipated, thanks to Jesse truncating his leaving remarks. That guy's done such an amazing job. Such an amazing job.
Woo! Jesse.
I think back to the hard work it took to get PyCon 1, 2, and 3 off the ground in 2003, 4, and 5, and I'm glad I put my stint in the early days. The logistics, the level of professionalism required, the sheer amount of work to do just keeps on growing every year. And you heard Jesse say that the foundation has pretty much decided that for now 2,500's as big as we really need to get. Nobody wants the essential community spirit of the conference to be lost, and some people are already feeling at 2,500 it's in danger, so you can be confident it's not going to grow much bigger. If only there was an open source conference company who could fill in the gap somehow.
If somebody knows one, let us know.
Let me think about that.
And we would like to ask Wesley, I guess it's Wesley Chan, to get to the front, and also K-Py
kpy at google.com. That's
Yeah.
Kping, I imagine.
Ping. Cool.
Ping, yeah.
So, our next speaker will be Jeremy Dunk about metrics as typical practice. Give him a big hand. Jeremy Dunk.
Hey, thanks. Just wanted to sort of give a general proposition that metrics should be basic practice as we now accept testing. If you can remember way back 2003, like it was before DVCS, it was really terrible times. Before Subversion even, holy crap, there was manual testing. Your manager would come to you and say, oh, we need to make a change, and you would have to be like, oh, I have to test the whole thing again. It's terrible. So what we've realized is that as we deal with things that are important and we have to get right, it's worth the investment of getting them right. We should invest the time to test them. And at first this was moonshots and telephones and banking, but it became reasonable for business as tooling and cultural value appreciated the value of automation. And eventually it reached down even to your toy open source project, things like Django. And it became like maybe it didn't have to be about a phone call. So how did we get here? There was this idea of agile and the ability to value things on both sides of the equation, things that are rules and process and procedure and communication and overhead, but also human interaction and value for the user and producing things in a consistent, sustainable way. And it's all about the cost curve, where when you really make huge investments early on, you make those changes or those investments in the hopes that you don't have to make changes later because they become more and more expensive, really expensive to fix a bug in a moon vessel. So how about this metrics thing? So there's this guy, Coda Hale. He recently gave a talk at CodeConf, basically saying mind the gap. That's the theme. I have no idea how I'm doing on time. I would say that Coda Hale is for metrics what Kent Beck was for extreme programming and unit testing. And they would both hate this claim, by the way. I'm just this guy off on the right on the picture there. So what's the idea of metrics? Right now we have a bunch of interfaces, ways of reporting, and then we have sinks, ways of displaying. And those things are right now fairly conflated, and also there's lots of choices that are accidental complexities. I choose JMX or I choose Graphite for my operations, but you choose something else, and now we can't share. We don't have a common way of understanding things. So how about metrics? Well, the way that Coda presents it is just a uniform interface. There's gauges, which are instant time values, counters up and down, meters. I don't have time to go into deep detail here, but meters are literally like a thing happened, a thing happened, a thing happened, and those get added up. Histograms, values over time, that's that chart over the right. Sorry, not awesome slides. Timers are basically, starting profiling, right? So what I would like to get to is a thing like XUnit for metrics. Now, I'm not saying XUnit is awesome for testing. No, there's PyTest, there's Nose, there's RSpec, there's all kinds of ways that we're testing. But the whole point is, first we had XUnit, which made it possible for us to even argue about the best way to test. We could at least test. So what I'm proposing for metrics is that there should be a way of doing reporting with minimal overhead. So because more metrics are better, and it costs too much should never be a reason not to measure. And then there should be an easy way to add app-specific metrics. There should be good interop between the metrics tooling and ecosystem. There's already an awesome array of stuff out there, but it's not well supported in our language, in our common culture. So ideally, I work on Django. I'd like to have a good out-of-the-box production sense of what's going on with Django as well. This one's controversial in core. How much metrics should we have? Yeah. So common non-blocking cheap interface, that is to say when you report metrics, it does something quick. You could put this in a tight loop and it doesn't matter. Decoupled producing and consuming, that is the way that you create the report is different than the way that you might choose to present it or consume it. And then wrapping utilities. You already have some existing code base. Some of it isn't going to have metrics in it. You'd like to be able to measure stuff, so how do you instrument that without actually changing the stuff that's upstream? So I'm going to do a bird of a feather at 5 p.m. in room 201 with Graham from New Relic, and that's my contact info and his contact info. And sorry for the pace here. And then he's working on a metrics PEP, which is basically supplying data sources. So instead of reporting things, making it easy for New Relic or other systems to reach into existing systems and get data, sort of like the gauge there. And then here's a bunch of citations for stuff I used in the presentation.
Thank you, Jeremy. Always an interesting talk. I was wondering what we could do for PyCon next year about lightning talks, and I was thinking maybe we could have like a lightning talk track, and I thought, well, that wouldn't really work because the speakers change so often. Maybe what we need is a Lightning Talk YouTube channel or something like that. Or maybe a Lightning Talk late night video channel. We'll think about it. We'll think about it. But I take it you would all like Lightning Talks next year, right?
So just a little test, you still know? What was the signal? Very good. And this? Great. Luke Gottsling will tell us the answers.
I will.
You will. Yes. Give him a big hand for the answers.
So I'm the co-founder of Contextual.io, and what we're doing is we're building predictive analytics for servers. So if that's something that interests you, sign up or come find me. So something me and the other co-founder, Alex Bendig, thought about for this year's PyCon is having something that people can do kind of out of band that still kind of involves the community, and we came up with a puzzle competition that a bunch of you attempted and a handful of you actually wound up solving. So what I'm going to present here are the questions and the answers to the puzzle competition that we ran. This was not one of the answers. So the first question is, create a string that consists of all letters of the English alphabet that are not also used in any of the keywords in Python 2.7, and ensure alphabetical ordering within the string. So you can just write them out and do it on paper, or you can do it in 2 lines. And that actually gives you the answer, which is these 4. So Guido, take note. These letters have not been used in keywords. Question 2 is, this will tell you where to go. The 2 equal signs at the end are kind of interesting. So many of you discovered that this is actually base 64 encoded. So again, it only takes 2 lines, and it gives you the URL if you base 64 decode it. Question 3, this was a description of a directed graph, and basically what we did is we had about 40 vertices between nodes, and so you could have written a parser for it, or you could have just written out on paper, and you had to find the shortest path from node A to node Z, and this was that path. Question 4 was, what are pi's decimal digits from 42 to 128? This is, again, something you could have looked up online, or there are algorithms for generating the digits of pi. Here is one of them. This is probably not a good way to write code, but the answer was these digits. This one was, again, some people kind of were scratching their heads about how this is not even a question, but in fact it is. This is a piece of Klingon text that translates to, "May your rival have an ugly neighbor." Question 6. This is a multiplication problem, but not a traditional multiplication problem. So no one actually solved this around Saturday morning, so we released a hint that this is not a positive base. We also told you that the answer was not that if you just did the multiplication in base 10 as usual. So this was actually a negative base. This was base -3. So then if you did the multiplication in base -3, you got this answer. And in base 10, that is the multiplication. And this was the last question. Again, this is very difficult, so we released a hint. Johannes Trithemius, he was actually the first person to coin steganography about 500 years ago. So we provided you with this image that was basically white background, and it said there's something off with this image. That's actually the image right there, and download it and see what's inside. And so what you had to do is actually look at what was encoded inside of the image. And so there's a very handy Python library for doing this called Stepic. So if you downloaded the image, you were able to decode the the string that was in there, which gave you this URL. Then that was the final question of the puzzle. And we had 10 people solve this. There were 189 participants that saw the first question, and we had these 10 people solve it. So congratulations to Adam Zakarski, who was the first person to solve it. We started it at Friday at 9 a.m. The first solution came in Saturday at 4:11 p.m. And last but not least, I want to give bonus points to the person who attempted to visit this URL.
Good. Thank you so much. Did we find Wesley at PolicyStat?
Not yet, no. Wesley at PolicyStat, are you ready to give your talk? Okay,
Cool.
Get up front, please. You're on deck.
Our next speaker is Wesley Chan about Core Python. Give him a big hand.
Thanks, everybody. Just want to see a show of hands. Does anybody remember this book that came out 13 years ago? Any fans out there? What's left of you? Everybody's dying and getting old, I know. That's why we're here to change to the next generation, all right? See, it makes a lot of sense. Look, quick history about this book. Since this talk is about the next generation, I want to give a little background. I was approached to write a book that was 500 pages long, and I told the publishers, you're crazy. I will not write a 500-page book on Python. They said, and then I suggested, how about 300? And they said, all right, why don't we make it 350 and we'll order the thick paper. And so, of course, I wrote the whole thing in Vim, and by the time they imported it into FrameMaker and formatted to like the rest of the other core books, it published at 810 pages. So that's what happened. And then for the next edition, I got smarter. I told them to not order the thick paper so I could add 300 more pages to the book. So that came out at 1120. And then in 2009, because I didn't want my book to die off, I added 2 new appendix sections for Python 2.6 and 3, just to keep it alive, because I discovered writing books takes a lot of effort. Unfortunately, it ended up being 1,100 pages, and the publisher asked me to work on a 3rd edition, and I said, there's no way we're going to keep going with this, so we're going to chop this book in half. And those of you guys who came to PyCon last year, I forgot to tell you, part 1, which was teaching you the language, is 670 pages, and then part 2, which is now that you know Python, what can you do with it? That's the rest of it. So what happened was I started working on these in parallel. So we're splitting it up into volume 1, volume 2, and I started working on both of them in parallel because I feel that multitasking is a good thing, right? Parallelism, concurrency, those are all good things, right? And then I discovered that, hey, part 2, because I added a whole bunch of Google stuff in there, I was able to work on that at work because it was a work-related project. And so that's what came out last year. Unfortunately, that's part 2. I really haven't made much headway with part 1. So part 2 became 888 pages. For those of you who are Asian, that's a pretty good number, I think. But I'm going to start looking at the next edition more seriously now because my publisher was looking for me. So since I wrote this book for the community, I really need help from the community. The main idea behind this book, the whole philosophy, is not just to teach Python syntax. The job of this book and my classes and whenever I give talks is to create great Python programmers. All right, so that's really the main focus. Don't get if you're looking for yet another book to teach you Python syntax. It does more than that. So I'm looking for your help. Specifically, those of you who have been doing Python for quite a while, I'm adding a brand new chapter on best practices. So if you have any ideas, your experiences are good and bad, interested in hearing about them, feel free to contact me. There's at least 4 different ways of reaching me here: Google+, Twitter, email, and the books also have a Google+ account. If you don't know how to use Google+, there's friendly URLs that you can send your browser to. But please reach out to me. I'm looking to try and get the next one ready for PyCon 2014 in Canada. Getting it through customs will be tricky, just like the passport thing, so we'll worry about that later. But in the meantime, I'm looking for people to help review the book as well as for people to help me add content to it. All right? Thanks a lot, everybody. Appreciate it.
Okay. Your hand.
Thanks very much, Wesley.
We've got a very important bug fix announcement for all Atari desktop users.
Oh boy. All
Brett
6 of them.
Cannon told me that he committed a fix that was just developed for the bug that Jeffrey Armstrong reported. So, all Atari desktop users, please upgrade immediately to Python 3.3.1. We would need E.H. Matters, gmail.com, to come in the direction of the stage.
Maybe the title of the talk would be easy, Abolishing the Traditional 9-12 Grade High School Structure with Python.
Yeah? Are you anywhere?
If the author of that talk... Okay.
He's moving.
Fine, excellent. So you just stay on this side of the stage, please.
Our next speaker is Ping about Q.Q, debugging output for tired programmers. Are you ready?
Yes.
Okay, give him a big hand.
Go Ping.
Enjoy.
Okay, so it's late at night. I'm tired. I'm trying to debug some code. It's not code that I wrote. It's actually some program I've never seen before, and I don't know how it works. All I know is that it's not doing what I want, and that makes me a sad dinosaur. So what do? Well, I start printing stuff out, right? Like, here's some code I'm in the middle of. I want to know what the value of this query variable is, so I'm going to type print query is query. Okay, now I'm going to run the program. But that's not going to work because this is some crappy web app, right? And like, who knows where a standard output's going to go. You know, if I try and load, here's the page over on the right. I hit reload. I just get like spew in my log output, right? Okay, so maybe what I need to do is, right, I'm going to print it to standard error. Okay, standard error. Fine. Okay, now I'm going to watch my logs, hope I catch it as it goes by. I'll hit reload. And of course, my web app crashes because I forgot to import sys. Okay, fine. At this point, swearing. Import sys. Okay, fine. Back to here. Watch. Okay, run. No output. Okay, now I'm stumped. Like, maybe this branch didn't get executed, or maybe standard error is getting redirected somewhere. I don't know. Fine. Okay, I'll do this the proper way. I'll use logging. Okay, import logging. Logging, debug. Okay. So how many of you have typed this particular line of code before import logging, logging.blah? Yeah, okay, we've all done it. Query, blah. Okay. So now I've used logging. Fine, that's what I'm supposed to do. So now you're happy, right? You're going to show me the output? Well, of course not. It's the bloody logging module. I mean, who knows what log level I'm at, or like what filters I have installed, or which handler, or like, my God, like, why don't you just show me the output? I just want to see the value of this variable. Like, why does this have to be so hard? All right. So I got tired of doing that. I wrote a module to do this for me. It's called Q. Why did I call it Q? Because I'm really lazy and I want to type as little as possible. Maybe it's because Q is the least used variable name in the Python standard library. Maybe it's because it looks like a person with two monocles, so they're twice as evil as one. Maybe it looks like a cat. Anyway, I don't type this anymore. I don't type this anymore. I don't type this anymore. I type this. Here's what happens when I type it. It's the shortest thing I could come up with. So here's what happens. Import Q to Q, query. Okay. And so you'll notice I don't actually type in any string here. I just type in the name of the thing I want printed out. And then the other thing to notice is that it doesn't go to the log file. It goes to a separate stream. It just goes to a file. So I can look at it separately. It doesn't get mixed in with all my other output. Okay, so I'm going to reload. Okay, so there's the wrapper of the thing that I tried to print. In front of it is the expression that I used to print it with, right? So I could actually type any expression in here. Like if I said Q.Q, 2 plus 3, for example. There's some like crazy introspection going on. So when I reload this, it actually shows me, 2 plus 3 was what I typed. So I can distinguish this from all the other times that I've called Q in my program. In front of it is get. That's the name of the function that was running. That's the function that the Q call is inside. And 5, of course, is the value. What else does Q do for you? Let me go back to my code here. So I can also trace functions. So I'll go up here on import Q. And again, because I'm lazy, the name of the decorator is T, not trace. I just want to go to bed, right, and get my work done, and I just can't be bothered to do any more typing. Okay, so I'm going to stick this in front of some of my functions. Right, there's another q.t there. And here's the output that I get when I run it. So it's just this indented display of my function calls, right? There are the arguments to the functions. So here's search, it got called with 2 arguments. There's the result, it's an empty list. And here's this other function call, and it's return value, another function call, it's return value. What happens if it returns a huge string? Okay, well, it knows that there isn't a lot of space here to print out this huge string, so it's going to save that automatically to a temporary file for me. If I want to see what was in that string, which is the rendered output of the page, right, there it is. So I can dig through this later and figure out what went wrong. Okay, so that's what Q is. It will be up on the packet index really soon, so you can install it like this or like this. If you want to print out stuff, do this. If you want to trace your functions, do this. I hope this saves you some time and allows you to get more sleep.
So, who do we need on deck this side, Harold?
We need Chris JRN at gmail.com from Australia. Chris?
Are you here, Chris?
I guess Chris Neugebauer.
Yeah, we'll put you in the queue. Okay, is Harry here from Python Anywhere, by the way? Okay, we'll try and make sure you get. Why don't we put Harry up next? He's been waiting.
Yeah, Harry.
Okay, fine. Who's after Harry for this side?
Charles Law.
Charles, are you here?
Charles, are you here?
Good, excellent. If you'd like to get to that side of the stage.
So, our next speaker is Wes Swinham, and he'll talk about neckbeard. Neck beard. On my list it was neck bread. So, about making deployment not suck. Are you ready?
Yep.
Okay, big
round of
hand.
applause.
Okay.
Okay, so deployment sucks for most people most of the time. You have big companies and you have people using PaaS, and for them it's fine. For the rest of us, it kind of sucks. So I think for the rest of us, maybe we can improve that situation. So I've done a lot of deploys. I've been deploying the same Django app, basically, DC2 since 2007. We have a homegrown system that I'm tired of maintaining, and we do a lot of deploys. So 400 relatively a lot of deploys. So we do a lot of deploys, which means deploys matter, and they affect our happiness, which matters. I'm tired of reinventing the wheel, and I'm tired of hearing about people reinventing the wheel also. So good production deploys are actually really hard. First you start off, you rsync some stuff and restart some stuff, and it's good. And then things happen. You say, oh, I need to add this other thing. So you have a wiki, and then you have to follow 3 steps, and then someone forgets that steps, and you're down. These deploys shouldn't let you break things, shouldn't interrupt customers. There's lots of properties of a good production deploy. If you have like a neckbeard guy on your staff, he'll make it awesome for you, and you won't have to worry about it. But he's also reinventing this wheel. So I would like everyone to have their own neckbeard guy, and we can work on it together. So it's easy to make a bad production deploy. PyPy's down, 500s, excuse me. EC2 instance goes poof, you get 500s. Someone forgets a step, they get 500s. You rotate it out to only working node from the load balancer, you get 500s. It worked on my machine. Yeah. So some of you don't care about this because someone else has already solved it for you. That's cool. These guys are not going to have to write deployment code. It's solved for them. Yeah, so you guys don't worry about it. You're fine. You have Deployinator and Borg and Asgard and Mesos and all these really cool things that are hard to understand, but they do the job. You have secret things that you won't talk about. If you're deploying WordPress, you don't care. There are good tools for this. If you have a hobby project, you deploy once per month, your Colo or whatever, you're fine. If you're on a PaaS and you love it, don't worry about it. But the rest of us, if you want to practice continuous delivery, deploys need to be awesome for your developers. They need to be quick. They need to work. If your customers care about your thing, you care about the zero downtime deploys. If your customers don't care, then, do whatever you want, whatever. If your deploy takes more than one step, you're going to break it. If you want to take advantage of dynamic scaling, if you have more load at certain times of the day, that's one thing the cloud lets you do. But if you don't have a tool, it sucks. If deployments give you butterflies, that's bad. We can do better. And if your disaster recovery strategy is like a document or like call the guy that knows what he's doing, that's not really a strategy. So we have orchestration tools and we have pool-based configuration management tools, and these are good tools and we should use them, but that's not the same problem. Orchestration is cool, but a real deploy is, I want to deploy and part of my servers and see if things are good and then roll back if they're not. I need to manage my EC2 nodes because I need to launch them a lot or take them down. And if my tool is step one, do a bunch of stuff and then deploy your thing, that's not really a tool. I need to own my backing services and my redundancy, and I need to detect that I'm breaking things. And these are not something that those do. Or they do sort of part of them, and then you have like Chef Server, Puppet, Salt Stack, same problems. Who launches my node? How to do partial deploys? How do I maintain redundancy that I care about because customers care about my thing? So let's stop writing the same glue code with Fabric and stuff. We're reinventing the wheel. And some of us are doing it badly, but we're all doing it worse than we could if we work together. So you probably have already done, Fabric plus Chef plus Bodo plus Bash plus yada yada yada. Now you're one-person Heroku. Congratulations. Good luck. You're not going to do as well. But with our powers combined, with open source software, if we can just agree on some interfaces, all of us little guys that are writing the same tools can reuse each other's code and write extensions and tie them together, and good things can happen. So I'm trying to do this. I'm frustrated. Some of you probably don't care about this. Some of you do. If you care, come talk to me. I'm open sourcing what I have, at least. I'm really want to work on interfaces. I want a one command deploy for everyone that's at this kind of in-between situation. Hooks, deployment, monitoring. I'm sprinting, so bring your stuff, come talk to me, tell me I'm crazy, tell me this is already solved somewhere. I'll be around. Thanks.
Wes Winham, ladies and gentlemen. Thanks very much, Wes. So how are we doing? Are you all ready for... Who's staying for the sprints, by the way? Quick show of hands. Oh, look at that. Look at that. Good on you. This is how projects move forward. Great. Okay, so next we've got Eric Mathis talking about abolishing the traditional 9th to 12th grade structure of high schools. Sounds suitably anarchic to me.
All right, good afternoon. This is a humble talk called Abolishing the Traditional 9th to 12th Grade Structure of High Schools. The unwritten subtitle is Using Python to Take Over the World. My name is Eric Mathis. If you like what you're about to hear, you can find me on Twitter. My blog is at peak5390.wordpress.com. These slides are up there. I teach high school math and science in Alaska. This is my backyard. It's a nice place for working hard and then playing. All right, so last year, Paul Graham asked us to fix search, fix email, fix universities, but when somebody asked him about high school, he said, don't fix that, it's too hard. So, is it? This is the kind of one-page summary of what I'm going to show you. You don't need to read this, but this is what we're going to take a look through. So, the answer to that question is competency education. In competency education, every new student in high school gets a blank map of everything they could possibly know, possibly learn in high school. Once that's done, our job as teachers in schools is to support students as they learn what they need to make their pathway through that map that they've laid out. All right, when you complete your map, you're done. There's no 9th grade, no 10th grade, no 12th grade. I see a lot of buzzwords in education. If you're still using traditional grade structures, you're probably not really doing competency education. So what this means is it doesn't matter if a person takes 2 years to get through their map or 6 years. When schools do this right, that's what happens. This is being done. And if you read research about how effectively schools are able to implement this model, they all run into one common technical issue. And that issue is if you're trying to present students with everything they could possibly learn in high school, you better have a pretty good system for organizing that. Most schools don't have that system. So what people are doing, I refer to this as the elementary school model. Every student gets a binder, maybe a poster on the wall, tracking their progress. A school might hire a developer for a one-off internal solution. And there's a few proprietary solutions that are coming about targeted at supporting this model. All right, but I'm a firm believer that proprietary solutions will never foster widespread adoption of new models of education. So free and open education tools can work. They offer instant adoption. If a school, all they have to do is create an account, use a web app, they can adopt it as soon as they get agreement. It offers continuous revision, offers inbuilt forking behavior. All right, so this is about a trio of tools: open education competencies, open curriculum builder, open competency tracker. What this looks like, this first piece is just all those things you can learn. This is roughly how it's organized. All right, and I put fork in quotes not for you all, because you all know what forking is. Educators don't know what forking is. So you have 100 teachers basically creating the same thing. All right, a school can continuously improve its system. Through version control, we all have continuous improvement. Schools don't have that. The last piece, if you're saying, oh, this can't be done, every school has to report on its state standards, you can map to those bureaucratically required reporting requirements. Second piece is open curriculum builder. So we all have Emacs, Vim, and Git. We've had Emacs and Vim for 40 years. So we've had efficient tools that let us focus on what's interesting in programming. Teachers are still building most of their curriculum in Word. So this piece of the project allows teachers to build lessons, projects, learning experience, assessments from those competencies that have been defined and continuously revised. It's for teachers, but it's also for anybody who wants to organize their own learning. From my conversations the past couple of days, people homeschooling their parents, people just graduating college and wanting to take control of their lifelong learning. Last piece of this, open competency tracker. This is the only security critical component. The rest of it is entirely public and open. And this is that complete blank map that every student gets. You get a copy, and we use that to track your progress towards graduation. This is the whole picture. If you like what you just heard, you can find that on peak5390.wordpress.com. There's a link to a GitHub repository because I've found some smart people here who will help build it. Thank you.
Eric Mathers.
Thank you very much, Eric.
Big hand. So, our next speaker, Harry?
Can you do that in 5? Yeah.
Steve? Harry Passwell about Python Anywhere.
Okay, hi everyone, my name is Harry. I work for a company called Python Anywhere, which I'd like to talk to you about now. In general, we all love coding Python, and I was wondering whether I could interview a few people and ask, for example, Yusa, what is your favorite place to code Python?
My office.
Perfect. Okay, and over here, you ma'am, what is your favorite place to code Python?
Starbucks.
Okay, but sometimes, we are able to code on our office, we can code on our laptops, we can code around the place, but sometimes there are places where we would like to code Python, but we're not actually able to. So for example, you, sir, can you imagine a place where you can't currently code Python, but you'd like to be able to?
Myself.
What's that? You'd like to be able to code Python after a 36-hour whiskey and Red Bull binge in a Thai internet cafe? Well, yeah, that happens to me all the time as well. How about some other people over here? I don't know. How about you, sir? What would be your favorite place to code Python? You can't currently do it. What's that? Shortly after winning a marathon, and you've been given an iPad as a prize, and in a sense of elation, you'd like to code an app to express your joy at winning the marathon, but you can't currently code Python on an iPad. Well, that happens to me too all the time. And all sorts of other people would like to code more Python. We talk to teachers who would like their students to code more Python, but they don't have it on their PCs. We talk to, for example, are there any data scientists in the room? Any data scientists? Okay, let me just ask you, sir. You would like to be able to code more Python on more PCs, is that right?
Yes.
But you have some dependencies.
Many.
Okay, like for example, you might have dependencies like SciPy and NumPy and PyFids and BioPython and Pandas and SymPy and scikits.learn and scikits.statmodels and scikits.timeseries and LXML and I've got a few more here, and MLPy and NLTK. We install about 500 packages. Anyway, it is possible there is a solution to this. We like to code Python in our desks, in our offices. We would like to code Python anywhere. We would like to code Python everywhere. And we are building a website to let you do that. Hopefully I have 2 minutes left to show you some screenshots of all this. There's no way I'm doing a live demo, but I have pre-prepared a bunch of screens. Okay. What are we currently showing on the screen? That's not too bad. Alt-tab. Okay, what about the front page? Looks like that. It's got a front page. Control. Page down. How about this? How about this? Supposing you built a tutorial and you'd like your students to be able to do Python right there on your tutorial. We'll give you an embeddable live console that you can plug into your tutorial and let people follow through an actual live console right there on your tutorial. What else? Okay, here's your front page. You can launch all sorts of consoles, Python 2.6, Python 2.7, 3.3, compiled brand new and fresh every single month. IPython in those 3 flavors, PyPy, Bash. You can have MySQL consoles. You get 500 megs of personal storage. You've got a full Bash prompt that's active and it's got color. You can have IPython. You can print hello world. That actually works. You can use VI in a web browser. You can also use Emacs. There's a full syntax highlighting text editor. It even gives you PyFlakes warnings about import errors and stuff like that. There are none in my code, of course. You've got a full free web app with every single account that you can have at yourusername.pythonanywhere.com. That's just free out the box. We've got quick starts for Django and Flask and Bottle.py and all sorts of web frameworks. We've got scheduled tasks if you want to kind of cron jobs and do web scraping. We've got MySQL connectivity and databases. That comes in the free accounts as well. And as I say, we've got a few modules for all you data scientists and people that might want some installed packages. Here is the list. It goes on and 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 on. That is Python Anywhere, www.pythonanywhere.com. Come and check it out. Love you all. It's been a fantastic conference. I am so happy to be here. You guys are all amazing. Big up all yourselves. Bye-bye.
Harry Percival, everybody. Python Anywhere. You can take your laptop with you.
You may want to take your computer, Harry.
And there's still 40 seconds left.
You know, I'm so glad we don't do commercial pitches at PyCon.
Would you have fries with that? After Rapid Speaker, we will have a Rapid Script. Charles Law will talk about Rapid Script translating Python to JavaScript. Are you ready?
Yes, I am.
Give him a big hand.
I forgot to say, you can share consoles with other users.
Down in front.
It's brilliant.
I always wanted to host the Jerry Springer show at PyCon. We don't have this stuff in Germany. Charles Law.
Hi, everyone. My name is Charles Law. I work at OpenX in LA, but I'm here to talk about a personal project that I'm working on with a friend called RapidScript, which is translating Python to JavaScript. So the first question a lot of people ask me is, why not just write JavaScript? And I just don't like it. It's not fun to write. You got to add semicolons. It's ugly. Like we learned the other day, Python is has lots of killer features. It's beautiful. It's fun to write. One of the other reasons is a lot of the backends that I've worked in are actually written in Python as well. So if I have Python in the front end and there's something I want to move to the back end, I don't have to do any work. So that's nice. And there's some tools already out there that do this, but they put a lot of effort into mimicking Python exactly. So when there's a certain behavior in Python that you don't need, like dividing by 0 is different between Python and JavaScript. And it turns out that you get this extra, your code is maybe 10 times bigger to catch all these special cases that you don't necessarily need. So we decided to create our own tool. So here's just a simple example of Python/RapidScript. It's a factorial function, and you see it looks just like plain Python. And when you compile it, you get this output JavaScript code. Not too much change. You get curly brackets. The numbers are still numbers. It's almost just a syntax change. But you have to be careful still. for example, the dividing by 0 acts a little differently between the two. So if you have code that divides by 0, you compile it into JavaScript, you might not get an exception. So you're not really writing Python, it just looks exactly like Python. So there's some other features we have on top of this. We don't just add semicolons and brackets. We also create classes using prototype, JavaScript prototypes, and this lets us basically do object-oriented programming in JavaScript. So I thought, what could I make? And the first thing I did was take a look at this other library called PyJS, formerly known as Pajamas, and I took their asteroids example, and I tried to compile it, and because JavaScript and Python aren't exactly the same, I had to make a few changes. And I have a visual diff right here of some of the files. There was only 3 files. And you can see I couldn't use some libraries, so this is the Python on the left and the rapid script on the right. I couldn't import random, which I used for randint and randfloat type functions, so I just created those in JavaScript. And this is probably something we should add, but the math module in JavaScript is a capital M, not a lowercase m, so a lot of places I just basically did a global, or I did a search and replace. But that was all I had to change. And I had to change a timer function, and that was pretty much it. So after an hour of work, I was able to get this output, which is a working asteroids game in the browser. And here's the code, the JavaScript code, and you can see it looks pretty simple, nothing too fancy. You can read it, it's legible, and it's not that long. So this was actually taken from another place. I thought, okay, what could I build myself from scratch? And I thought of a game that I played a long time ago called Chips Challenge. And I had a parser, I had a parser for it that would read level files. And so first thing I did was port that over to RapidScript. Then I started creating objects or classes for the different objects in the game. So I had walls, tiles, players, blocks, and I just kept adding things. And after a day or two, I was able to actually play the game in the browser, loading the original game files. So this is it. I made some custom images. I actually call this game Cyborg, so hopefully I'm not infringing on any copyrights. But this is the original game playable in the browser with a custom skin. So this is one of the first few levels. You can see we changed the water to acid because it sounded more cyborgy. And so if you hop on there, it actually dies. This doesn't have any alerts or anything.
Charles Law about RapidScript. Have you seen? We now have asteroids in the browser. So we don't need to fix Python on the Atari anymore.
But we're platform agnostic, right?
Platform agnostic. Our next speaker and final speaker, Christopher Neugebauer.
Hello.
Woo.
Hello, Python lovers. How are you today? So I run a conference in Australia called PyCon. Hello. This is actually switched on. Hi. So I run a conference in Australia called PyCon Australia. It is in the first weekend of July, and we have a call for papers open at the moment. It closes on April the 5th. Here's a photo from last year's conference. Now, we have far too many people proposing talks whose name is Bruce, and it would help me a lot if we had a few non-Bruces. So please submit to our call for papers. All the information is at pyconau.org, or check our Twitter account as well. So I still appear to have plenty of time left, so I actually have a lightning talk canned. I have the wrong thing here. You may have seen me in such lightning talks as job security in Python. And a few years ago, I presented that same lightning talk in front of this guy. Do you know who he is? That's Damien Conway. He's sort of like the David Beasley of the Perl world. And Damien informed me at that conference that apparently unmaintainable code was the exclusive domain of Perl. And he said to fix this problem, that I was to become an honorary Perl monger. And I could just not cope with this because Python is not like Perl at all. You know, you type import this and you get this thing, you get this thing that shows up, and then you get this thing that says there should be one and only one obvious way to do things, and that's the exact opposite of what Perl does. So I thought, what else can I pinch from Perl? Because, you know, their hobbies, we want to have them as well. I had this game called Code Golf, where the idea is that you take a piece of sensible code and you come up with the shortest possible implementation as possible. And you know, Python has really well-defined structure. You try to make your code readable. So here is an implementation of quicksort in Python. It uses list comprehensions and stuff like that. It's 3 lines. That's 141 characters. It uses list comprehensions. Now, if you change some of the variable names, you can do that so that you check for the emptiness of a list just by getting rid of the len equals 0 thing. And that went down to 119 characters. Now, I did manage to get it down to 116 characters by crowdsourcing. And so some people on Twitter gave me these answers. Firstly, they gave me something longer. That's not terribly good. 147 characters wouldn't even fit in a tweet. That's dreadful. But then we got some progress. People replaced their function definitions with lambdas. And using the ternary operator means you don't need to have return statements. So that's great. So there's lambda, and that's 106 characters. So we're getting better. So the shortest implementation I got of quicksort, it uses this short-circuited AND operator. And that returns the empty list if the list is empty, otherwise it recurses. And that's 88 characters. And then people realized that they didn't really need to implement quicksort. They could do other things. And so here is some tail recursion. See that thing at the end? And that implements selection sort in 92 characters. But then you can sort of get rid of bits like that. Get rid of spaces by using the semicolon. You can have semicolons in Python, so that's just like Perl, right? Great. And that saves really valuable space characters, so you can get 74 characters there. And we got down to the shortest in-place implementation of selection sort, which was 54 characters. Or by using the pop function, you got it down to 45, which is our winner. But I saved the last word for Nick Coughlin, who said that the only sorting algorithms you need to know are list.sort, because Tim Peters has read Knuth for us. So yeah, get along, submit to our call for papers at PyCon.au. I really want to see heaps of you down in Australia in July. Thank you very much. And thanks to Steve and the Lightning Talk man for the Lightning Talks. It's been great throughout the entire conference.
Thank you very much.
Thank you. There was an interview question when Obama interviewed for Google. They asked him about how to sort a list of integers.
Oh, I remember that one, yes.
If he would have known Python, he would just have sorted. Yeah. That's right,
yeah. And the whole thing would have been sorted, as we say in England. Ha ha ha. The only other Englishman in the room thought it was funny. Oh.
We should give all the speakers a big hand.
Absolutely right. Thank you all.